Okay, separable equations, it actually says in the name really what you're going to do is you're going to separate the two things. So here, I know it might not make sense just looking at that, but do you see how this side just has y's? So you've got your y, you've got your dy on this side. The other side just has the x's. So you've got your x's in here and your dx in the back. So what you're going to do is you're going to separate the dy dx, and you're going to get all your y's on the side with the dy and all your x's on the side with the dx. So as here, a separable equation is a first order differential equation. That means there's a first derivative. So you guys know that dy dx is equal to y prime, right? So if this said y prime, the first thing I would do is I would switch that to dy dx because it's easier to solve if you can see the dy and the dx in it. If you see dy dx on your AP test and you're not sure what to do, a lot of times it's a separable equation where you want to separate those variables and then integrate or take the antiderivative of both sides. And a lot of people just don't recognize what to do, so then they don't earn those points. When a question like this is on your free response AP test, the part A for this is the slope fields. So you have to draw a slope field at like 9 or 12 points. And then typically part B is one of these. And this question is worth 5 or 6 points, which is like humongous. Just this part, like part B is worth 5 or 6 points. So that's like a crazy amount of points for one little portion. And I would say it's one of the easier questions typically on the AP test for like free response. But you have to know like, okay, I'm doing a slope field here. Look at the next part and say, is this a separable equations type problem? Because if it is, you can do it and you can earn points. I'll show you where you earn all of the points because they're pretty easy to earn here. So what it's saying here, dy dx can be factored as a function of x times a function of y. So you're separating your x and your y, and then you move your y's to one side and you move your x's to the other side. So integrate both sides. How would I get this dx so it's not in the denominator? Times by dx. So if I times by dx, wouldn't dx just cancel on this side? And then it would just be this whole thing times dx on this side. So that's really always your first step, is to times by that dx, get it on the other side. So do you see how I have all my y's on the left and all my x's on the right? So after you get all your y's over here and all your x's over here, what you're going to do is put an integral sign in the front of both of those. So really I have now the integral of y squared dy equals the integral of x plus sine of x dx. And on the AP test, you literally just earned a point because you separated the equations. So just getting the y's on one side, getting the x's on the other gets you a point. Okay, your next point comes from actually integrating this side. So what is the antiderivative of y squared? 1/3 y cubed. So we have that. Now, we need to have a plus c. But if I put a plus c on this side and a plus c on this side, yeah, but do those have to be the same constant? No, this could be 3 and that could be 1. So you just have to be careful not to use the same letter for those. Or really, if one side has a plus c and then the other side has a plus d, couldn't you just combine those together by subtracting that over? And don't you just have a constant on one side then instead of a constant on both sides? Okay, so the plus c really only needs to be applied to one side. And typically, for whatever reason, that's done on the x side, but it could really be done on either side. So if you're afraid you're going to forget it, you can put the plus c here. Typically, we put it on the x side because we're going to solve for like a y equals at the end, and it's one less step at that point. Okay, so on this side, if I take the antiderivative, what's the antiderivative of x? Half x squared, and sine turns into negative cosine. And then don't forget the plus c. And I'll show you where you're getting points here. So AP test, you get 1 point for this. you get 1 point for this, and you get 1 point for that. So do you see how easy those 4 points are? That's like the easiest 4 points. Like, I mean, there's definitely some questions that are easy, like take the derivative and it's basic stuff. Like, those ones are obviously easy points too, but free response questions tend to have a lot of questions where maybe you're not sure what to do. So if you know what to do here and you can do it, you earn a lot of points really quickly is the nice thing. It doesn't take a long time to get there. Okay, now the other thing that you could earn points for that this problem doesn't have is sometimes they'll give you an initial condition. So they might say that like your x equals pi when your y is equal to 1, and then you can plug those in and solve for what your plus c is. This one doesn't give you that. So if that was given to you, you could earn another point for solving for what the c value was. So some of them will have that, and you'll see that probably on the next page of notes, I believe. And then the very last step would be to try to get the y by itself. Sometimes they don't award a point for that, and sometimes they do. So I'm just going to tell you to do it because you don't want to lose out on an easy point there. So to get the y by itself, what would you probably do first? Times by 3. If you multiply everything by 3, what I've got is y cubed equals 3 halves x squared minus 3 cosine of x. And then instead of plus 3c, typically your book will just change that to a different constant. Or maybe they'd put this as plus d and then put this as a plus c. You know, so if you see a plus c and you have plus 3c, just realize they're both constants, so you're not wrong. And then to get rid of the cubed, you do what? Cube root, so you just have y equals the cubed root of that whole thing. So is there anything in there that we feel like we can't do? And typically they're pretty straightforward like that. You know, like the antiderivatives aren't anything crazy. It's not like you're doing u substitutions and stuff in there, or like integration by parts and stuff in there. But in the homework, you're definitely doing that. And in college, I feel like the class is a little more difficult than like what the AP test expects. So if you do get to this in college, you'll probably see what is in the book a little bit more than what I'm telling you is on the AP test. So doing that book work is not going to hurt you at all. Okay, this here is definitely a more difficult problem. And I don't want to say it's not going to be on the AP test, but or something like this that this hard won't be on the AP test, but it probably wouldn't be because people have such a hard time recognizing it to begin with. If you see something like this and you know that you're trying to solve the differential equation, first step would be to change this to what? dy dx. So wouldn't that put a dy on this side and a dx on this side if you multiplied it over? So you know you want to separate these so that you have your x's and your y's in two separate things. And that's kind of the hard part of this problem. So let's try to factor this so that I have all my y's over here and I have all my x's over here. Okay, so factor it so you have a binomial here and a binomial here. I'm going to give you guys a minute because I know that you're more than capable of doing that. I'm not saying it's easy, okay, but go ahead and try it. Okay, so what'd you put in the first parenthesis? Y plus 2. And I probably, just because of how I'm looking at this, I would put 2 plus y, but what you put is completely fine. I think this will be easier to show people who didn't get it. And then back here, what'd you get? 1 plus x squared. So if we FOIL that, we want to see if that comes out to what we have up there. So all I really did to do this problem is I looked here and I said, okay, when I multiply the two pieces, I need to get an x squared and a y. So that's why I would put a y here and an x squared there, because I know that term will turn into that. And then I know in the front I'm going to need to get 2, so I'm going to need a 2 and a 1 to get that. And then figuring out which spot the 2 and the 1 go into, you need to get a 2x squared, so the 2 and the x squared have to be in opposite ones. And you see how the FOIL works on that one? Okay, like I said, it's not a super typical problem. The rest of this problem is very much on the AP test, so I don't want you to feel like this whole problem is not going to be seen. Okay, so we said that this is dy dx, so the dx, we just multiply it to the other side, right? So if you have something like this where you're multiplying to get the y's to the other side, what do you do? Divide. So you're going to divide both sides by 2 plus y. And that'll cancel it here, so then you're going to have 2 plus y in the denominator on this side. So really I've got the integral of 1 over 2 plus y, or y plus 2, whichever way you want to write it, with the dy. So a lot of people end up with this in the numerator. You don't want that. If it's dividing, it's in the denominator. And then on the other side, we've got the 1 plus x squared with the dx. Is that looking okay? Are there any questions, or if I made any errors here? And this one, you could do a u substitution on it, but I want to show you a shortcut in case you're, not wanting to do u substitutions on very basic u substitution problems. You guys know the integral of 1 over y would be what? What's the antiderivative of 1 over something? It's a natural log, right? And that works, it's absolute value then. That works if it's linear in the denominator. If this was like y squared, you would move it to the numerator and you'd add 1 to your exponent, right? So just be careful of that. But if it's linear in the denominator, you can do this. Is this linear in the denominator? Yes. So if it's linear in the denominator, we're going to do that. So we do the natural log of the absolute value of y plus 2. And then what you have to be careful of here is multiplying by 1 over the slope out front. So what is the slope of that linear equation? What's the slope of this? Think of this as x plus 2 instead of y plus 2. What's the slope? One, right? It's whatever's in front of the x. So do I need to multiply by anything for this one? No. Okay, maybe write on the back of your paper or something. You got a lot of room back there. Okay, if you have the integral of 1 over x, let's just use x's so it's less confusing. This is just the natural log, the absolute value of x. So if I have 1 over x plus 2, which is like what we just did, that's the natural log, the absolute value of x plus 2. There's no slope, or there's a slope of 1, so there's nothing crazy there. And then this is where it saves you from having to do a u substitution if we have 1 over 2x. What's the slope of that one? What's the slope of it, though? 2, right? So you do natural log the absolute value of it, because it's linear, so you can do that. But then you have to do 1 over your slope out front, okay? That trick will work for other things, too, not just for, like, the natural logs. So it's definitely something that's worth kind of focusing on and memorizing. Okay, you do 1 over the slope. So if you have, this is kind of in general, 1 over mx plus b. So a linear equation here. You do 1 over the slope, natural log of the absolute value of that line. So questions on that at all? I'm going to show you the other one where this comes up a lot. Might as well write them down. It's not going to hurt anything, right? So let's say I've got the integral of e to the x. What is that one? Just e to the x, right? Now remember, these should have plus c's in the back, but we're going to end up with limits on them, and sometimes that plus c is not going to be there. That's not the focus of what I'm talking about here. Okay, e to the negative x we just had in a problem today we were doing, so what is that? Negative e to the negative x. So you leave your exponent the way it was. So if we have, let's say, e to the 2x, you see how it's still a linear piece up here? So if it's still linear, you can still use the e to that power. So the e to the power doesn't change. So it's still e to the 2x, and you do 1 over the slope out front. So if we do 1 over the slope, it's what out front? A half. And if you think about this, if you took the derivative of this, you leave the half alone, the derivative of e to the 2x is e to the 2x, and then you have to multiply by 2. Do you see how that gets you back to there? Okay, so if you're ever not sure, you can always, do it and make sure it gets you back to there. Otherwise, you could do a u substitution. You guys have just done the u substitution stuff. So if you were doing a u substitution on that, you would make your u 2x. So the derivative of that is 2 dx. And so then your dx is du over 2. So this integral turns into e to the u, and your dx turns into du over 2. So do you see how that ends up with a half out front? And then you have the half out front, that turns into, oh sorry, that should have been e to the u, and the u turns back into this, okay? But u substitutions require time, so if you remember that it's 1 over the slope for linear things, it makes it a lot quicker, okay? So let's keep going with this problem and try to get this one done, and we'll do the next one tomorrow. Okay, so this is natural log absolute value of y plus 2. This side over here, what's the antiderivative of 1? X. And remember, this side we're dealing with x's, so it's x. If it was on that side, we would be dealing with y's, so just be careful what variable. And the x squared turns into 1/3 x cubed. And what do I need on one side or the other? Plus c. So questions on that at all? Now, if we're trying to solve this for y equals, who knows what to do? Anybody? How do I get rid of a natural log? You would go e to that power, right? So we're going to go e to this power is equal to e to this power. Okay, so that's called exponentiating both sides. So what happens on this side if I go e to that power? The natural log cancels, so it's just y plus 2 and its absolute value. And this is really where there's a trick that you'll see on multiple choice. So for multiple choice, their answer is going to look different than what you would be able to do if you didn't know this trick. So that's why I want to make sure that we see this. Pretty good chance you're going to see it on the AP test every year. So, okay, this here, if you have adding things in the exponent, you add your exponents when you have the same base, right? So do you see how this is equivalent to what this is here? Okay, when you have the same base, you add your exponents. Isn't e just a number? So isn't a number to the c just another constant? So I don't remember if the book uses a or k. One book I use does one and one does the other. It doesn't matter what you use. Okay, this then we can just switch to a new constant. So let's just call it a. So this turns into y plus 2 equals a e to the x plus 1/3 x cubed. Do you guys see where that comes from? That kind of looks jumbled in there. Yeah, so at that point you can get rid of the absolute value, because the absolute value is kind of like, oh, it could be positive, it could be negative. This constant absorbs that positive or negative piece. So at that point you can get rid of that absolute value. And then what's the very last step? Subtract 2. Does that minus 2 go in the exponent? No, the minus 2 is down here. Okay, and that's another easy error for people as they put it up there instead. Okay, so questions on that? Okay, and we'll do this last one then tomorrow. And there's some homework that you can start. I would definitely try to start some of that. You're going to get to a lot of those where, okay, you separate it, and then when you have to do the antiderivative, you might have to use like a U substitution or an integration by parts. So if you get stuck with that, just move to the next one and try to separate it. You know, get some of the easier work done on them, and then we'll have a work day tomorrow after we do that very last question. Okay.